Hello everybody, I'm very happy and honored to be here. And I'm also very happy to see so many developers here. Great job, guys. So today we'll talk a little bit about Kotlin. At this moment, in the world, there are more than 5,000 programming languages. Now, the first question asked by us, the developers, is why do we need another programming language like Kotlin? The purpose of my presentation is to show you some basic features from Kotlin in order to help you understand what are the main advantages of this new language, Kotlin. So my presentation will be split in 5 main sections, and we will discover how this language was designed, what are the main basic control flow instructions, how are we able to work with classes, with functions, with collections in Kotlin, and finally, we will make together a review on some examples with coroutines. So let's start. What is Kotlin? Actually, Kotlin is a Russian island located near St. Petersburg in the Baltic Sea. And what do you think it exists in St. Petersburg? In St. Petersburg, there is the R&D center of JetBrains, and Kotlin is made by JetBrains. So this is from where they took the name of the language. Actually, Kotlin, in our case, is a general purpose programming language that works also for oriented object programming and also for functional programming. Other than that, it's open source, but it's mainly developed by JetBrains, and they also they were supported also by the community because they asked the feedback from the community when they develop some features in the language. And other than that, it's a statically typed language, so it means that we also, in Kotlin, are able to skip the type when we define a variable. What is the philosophy behind of this language? The philosophy is to create a modern and pragmatic language for the industry, not an academic one. Pragmatic means that it helps us to get things done, And in terms of software, it means that we are able to implement easily our ideas in software. Kotlin was started as an internal project in JetBrains in 2010, and it took about 6 years in order to validate the design changes. And they all the time they checked their features with the community because they wanted to create a language for developers, not for the universities or for the academic environment. In 2016, they launched the first version, and in 2017, Google officially announced that Kotlin is the first-class citizen in the Android world. In 2018, they launched Kotlin 1.3, and this year they launched the latest version that is currently available, Kotlin 1.3.15. Also, the popularity of this language increased in the latest years, and right now it's the 4th most loved language from Stack Overflow, according to a survey made by them. And the adoption has increased in the latest years. And here I have a question for you. What do you think happened here? Yeah, Google announced that Kotlin is a first-class citizen language in Android, so the adoption increased a lot. Right now there are about 1.5 million of developers in the world. Okay, what kind of applications are we able to develop using Kotlin? We're able to create server-side applications because it offers some interoperability with Java, but also able to create Android apps, browser apps because Kotlin will be transpiled to JavaScript, and we are also able to create native apps like iOS apps or apps for Mac or for Windows because they offer also support for all the languages that work on LLVM compiler infrastructure. So we have here a lot of possibilities. Now let's see what kind of developers we have here. Who is a Java developer? Okay. C++? Good. PHP? Okay. JavaScript? Okay. I see here a lot of front-end developers. And Scala maybe? C#? So I understand that the rest of you are Kotlin developers, or what I've missed here. Okay, we will see. There are also a lot of Android apps developed in Kotlin on the market. The big companies are using Kotlin. Companies like Twitter, Pinterest, Trello, they started from the beginning to move their apps in Kotlin. In terms of conventions, we are able to use the same conventions like in Java. For example, for types we are able to use uppercase, and for the variables lower camel case. But there are also some specific rules in Kotlin. For example, the semicolons are optional. So we are able to write without semicolons at the end of the line. And other than that, the file could contain many classes, and also a folder the name of the folder could be different than the package name. In terms of development tools, like I already mentioned, it offers interoperability with Java, so we will be able to use JVM 1.6+. And we have also the Kotlin compilers. And in terms of development tools, we could use IntelliJ, Android Studio, NetBeans, and Eclipse. JetBrains offers support. They have some plugins also for NetBeans and Eclipse. About the interoperability with Java, the process is very simple. All the files that are written in Kotlin have the extension KT, and they are compiled to some .class files. And after that, they are packaged in a jar file, and that jar file is compiled and finally is created and released in an app. In terms of build tools, we have also many possibilities. We could use Maven, Gradle. There is also Cobalt, that is something dedicated to Kotlin. It's created by them. Or even if we want, we could build the code using the command line. Okay, Kotlin basics. Like any other language, we have some types. In Kotlin, we have only objects. We don't have primitives, like in Java, for example. And in order to define some variables, we have two possibilities. We could create an immutable variable by using val, and it means that that variable will be read-only, so we are not able to change it. Or we could use var, which means that it's a mutable value, and we are able to change it. Like I already mentioned, it's a statically typed language. So, for example, in this case, when we have var sum of numbers equal 0, it is not necessary to specify the type because the type is inferred. So the compiler will know that it's an int. For the second example, since we define the name of the variable but we don't initialize it, we need to specify the type because the compiler should know what kind of type should be allocated for that variable. String interpolation. In Java, we don't have string interpolation, and it's not so used in many languages. In Kotlin, we have, and it's done by using the $sign. And if we have an expression, for example, if we want to get the length of a name, name.length, and we want to put it in a string, we will use $sign combined with curly braces. We also are able to keep the format. So if we want, for example, these words to be written on the first line and the second one on the second line, we are able to use the row strings. Control flow. Just like in any other languages, we have 5 different control flow instructions. We have if, when, for, while, and do while. And the difference is that they work also like expressions. So we are able to get the value of those expressions. Let's see some examples. We will start with if. So here we have a number, and after that, we check that number to see if it's greater than 0 or not. If it's greater than 0, it will return this value. If it's a smaller negative number, and if it's 0, it will return 0. In this case, what do you think will print at the console? 0, great. Next one. When. When is like switch with superpowers. Because it could be used differently than the other languages. It has many extra features. In this case, we check if our operator is this one, the slash, and after that we print the result. What will be printed here? Exactly, 2. It will print 2. Another example is with range. In Kotlin, we are able to check if a number is part of a range. And this thing is possible with this operator, in. And if it's not part of the range, we will negate it. So we will add an exclamation mark. In this case, what do you think it will print? It will go on this one because 22 is not in the first one and also in the second one. When we check type, also when we use when, we could check if our type is int or string or any other type existing in Kotlin. So here, what will display? It's an int or not? It's an int. So it will display the first message. Great, you are doing a great job. Okay, 4. 4 is similar with other languages. It's used in order to iterate in some elements. Here we have a range between 1 and 10, and it will take each index and print it. And here, in order to create a 4 that will go in descending order, it will use this down to operator. So it will start from 12 until 0, and the step will be 2. So it will print, first of all, 12, 10, 8, 6, and so on until 0. 4 with index. We're also able to get an element from a collection or from a list by using the brackets, the rectangular brackets. So this one is similar with inhest4 from Java, and the second one we just iterate in our array by using the indices property, and after that we access an item based on their index. While and do while. Here they don't have any huge changes. It's the same approach. The body is executed as long as the condition is true, and here also the same idea. Equality checks. In Kotlin, we are able to check the equality, structural equality, and in this case we have 2 sets of strings, and when we want to print this result, we will get a true. Okay, now about the $1 billion mistake. This is the quote from Tony Hoare, who recognized the fact that the invention of null was a huge mistake. And now the guys from Kotlin are trying to solve this issue somehow. Let's see what is the approach. They try to create actually 2 kind of types. Sometimes that support null, and the other ones that doesn't support null. In order to support a null, we need to add a question mark next to the type. So if we want to have a nullable int, we will write int and question mark. But there are also some situations when we are able to get a null pointer exception, and there are 4 scenarios. The first one is when we throw the null pointer exception, and in this case we don't have any escape. In Kotlin there exists this non-null assertion operator, and this operator lets the compiler know that we know for sure that our variable is not null, and the compiler should trust us. And in that moment, if the variable is null, we will get a null pointer exception. Another possibility is when we have some inconsistency, related to the initialization of some variables. So when we maybe initialize something that we are not aware about the fact that it's a null, and since it's interoperable with Java, it's possible also to get a null from there. In order to check if a variable is null or not, we have 2 options. The classical conditional if, in this case, and also we are able to make some safe calls to check if our variable is null or not. For example, in this case, platform is a nullable string, so we are able to define, to initialize it as a null. And by doing this safe call, when we print this message, usually if we don't have that safe call, we will get a null pointer exception because the platform is null and it's not able to get the length of the null. But since we are using this safe call operator, it will return null, and that's it. So we will not get an exception. For the second one, it's not necessary to create a safe call because we know that it's not a nullable type. If we use the double question mark operator, in this case, when we apply to the platform, our variable is null, so we will get a null pointer exception. We also have this possibility to make a safe cast. In this case, if our length is not null, it tries to cast it to an int. So if it was a null and we try to cast it at a type, we will get also an exception. In this case, it will check it, and if it's not an int, it will work. We will not get an exception. The second option to check if our variable is null is by using the Elvis operator. Do you understand why it's called Elvis operator? So we have a variable name that is nullable, and we want to take its length. And since it's a null, it's not possible to get a result, an integer result in this case. So the Elvis operator, in this situation, since our name is null, it will display the value after the Elvis operator. So it's like a default value. Do you remember there were some situations when you, in this case, for example, if you wanted to write it in an if way, you write if name is not null, display the length. If name is null, display -1. It's like a default value. All this if else, it's somehow shrink it here. So you write it only by using one single line of code. So in this case, it will display -1 because our name is null. Functions. In Kotlin, the functions are created by using the fun keyword. So we have a lot of fun in Kotlin. The main function is written like here. This is the syntax for the main function. And in order to understand better the structure of a function, we have, first of all, the function name, the parameters, the return type, and the body of the function. An interesting thing in Kotlin is that we are able to write the same function in different equivalent ways. So, for example, in this case, when we add two numbers, this function is equivalent with this one and also with this one. So we are able to write expressions by using only one line of code. Okay, another helpful feature in Kotlin is the ability to have some default parameters. In this case, the prefix is the default one. So we are able to call this function by using both parameters or by using only one. And when we use only one, it will take the second one from the default value. This helps us a lot with the overloading of the functions. Because in Java, for example, if we want to get the same feature, we will write two functions. Named arguments. There are some situations where we have a function with multiple parameters that have the same type. Let's say we have a function that has 3 int parameters. And when you call it, usually you don't see it near you, so you need to remember what is the order of the parameters. In Kotlin, it's not necessary to remember the order, because we are able to call the function by using the name parameters in which order we want. So in this case, I define the function with first name and last name, and after that I call it using first the last name and after that the first name. So the order doesn't count. The important thing is to specify the name of those parameters. Infix functions. Infix functions are functions that have only one parameter. And the advantage of this function is that we are able to call it by using the classical approach with parentheses or by using just the name of the function. So this call is equivalent with this one. And in both cases it will work, and for this one we'll get this pair, blue shoes, and for the second one, the second pair, yellow scarf. So this is the main advantages of infix functions. Also in Kotlin we have our arguments, so if we want to specify maybe 0 or many parameters, we will use the vararg keyword. The difference that exists in Kotlin related to Java is that we specify this keyword in front of the name of the parameter. In Java, we specify next to the type of the parameter. So we are able to call this function with 0 parameters, or maybe with 1, with 3, whatever is necessary in our scenario. High-order functions. High-order functions are functions that get another function as a parameter or returns a function. Here I have an example when I return a function. So I have the add function, which computes the sum of two numbers, and I return it for this one. In order to call this function add, I will use this notation. Lambda, we have also lambdas in Kotlin. Lambda expression is an anonymous function, and it's a function that is not declared, but we could use it as an expression. In order to define it, we need to specify the curly braces in order to let the compiler know that there we have a lambda expression. The parameter will be in front of the arrow, and the body of it will go after the arrow. Let's see an example. This is a lambda expression that calculates the sum of two numbers. And in order to call it, we do it just like with any other functions, in this case with two parameters. So it's pretty straightforward. Another example, it's by using the when in this case. So here is the parameter of it. So it's put in front of the arrow, and here is the body of the lambda function. And try to check the code and let me know what it returns. Actually, what it prints. Yes, that's great. Extension functions. This is a very nice feature, but we need to use it carefully. What does this extension function? An extension function, it's a member function, so we declare it in our class, but it could be applied to another type. I think you remember, maybe you have used in some projects that famous class string utils, or helpers, or just utils, where you have a lot of static methods that you call it all over around your project. Yeah, the extension functions are doing the same thing. Actually, behind the scenes, it converts this function to a static function. So it doesn't change the structure of the type on which it's applied, but it adds a static function to that type. Let's check an example. For this situation, I create an extension function for the string class, for the string object. And my function removes the first and the last char from a string. When we define an extension function, we need to have the receiver type and also the receiver object. In our case, it will be this. So this is how we write it, and in order to be called, we will apply it to a string. So we apply this function to this Kotlin string. And it will remove the first and the last char from that string. And we will get this small string. Classes. Also, in Kotlin, since it's an object-oriented programming language, we have classes and objects. Like in any other language, classes are blueprints and objects are instances of those classes. Let's take some examples. We have here two functions, report error that throws a runtime exception, and a function called display hello message, which prints a message. Here, the first one returns a nothing, and the second one a unit. Actually, these two classes exist in Kotlin. Nothing is used when we don't want to return anything. And it's very helpful in situations where maybe our function has an if and without an else, let's say. So I have if name is, the length of the name is greater than 3, then return a string. And usually you don't want to get anything else if it's if that condition is not met. And usually in our other languages, you put something default, return, I don't know, -1, and you know that -1 in this case, it means that the length is not possible to be calculated. So this nothing is very helpful in these situations because you are able to return nothing. So if the condition is not met, it will go on the second option. Unit, it's similar with void. So if you don't want to have a return type, you specify unit. By default, if we don't specify it in our functions, Kotlin knows that it's a unit. The difference between void and unit is that unit actually is a singleton. So we are able to get only one instance of that object. Other than that, any is the parent of all classes. It's like object in Java. And by default, it contains implementation for toString, hash code, and equals. In order to define a class, like in any other oriented programming languages, we have constructors. We have the primary constructor, and for the other ones, if you maybe want to create a second one, we need to specify the keyword constructor. So we have some secondary constructors. Let's see an example. Here we have a class, person, and here actually, between the parentheses, that is the constructor. But this line of code is doing a lot of things. For example, we have the constructor that contains only one parameter, the full name. And the fact that we specify that it's a val, it creates by default a property for this full name. In Kotlin, we don't have fields and functions. We have properties and functions. So we don't access directly the fields, we access them by using the properties. And since it's an immutable, it means that we have only a getter. We don't have a setter for this property. So the code that will be created for this situation in Java had usually 20 or 30 lines of code. In this case, we write only one line of code. In order to specify a secondary constructor, like I already mentioned, we will use the constructor keyword, and we need to also refer the initial one, the primary one, by using this symbol. And for age, for example, if we want to change the getter or the setter, for this situation we are able to change only the getter because it's an immutable property. We are able to use this notation, and in this case it will return 18 all the time. To create an instance of the class, we don't use the new keyword, we just specify the name of the class and the parameters that we want. Visibility modifiers. In Kotlin, everything is by default public. If we want to change the access modifiers, we have different possibilities. For packages, we have private and internal, and inside of the class we have private, which means it's accessible only inside of that class. We also have protected, that it means that it's visible inside of the class and on subclasses. And internal, that it means that it's visible inside of a module. A module is a set of classes that are compiled at the same time. Inheritance. By default, in Kotlin, all the classes and functions and properties are close to be inherited. So the classes are final. We are not able to extend them if we don't specify the open keyword. So if you want to extend this class, the person class, we need to specify the open keyword, and the same idea appears also for properties and for functions. And when we override the properties and the functions, we need to specify the override keyword. In Kotlin, the keyword object has a different signification. It means that we create a singleton. So we get a singleton only by specifying this keyword. In this case, we will be able to get only one instance of the object class. Abstract classes. An abstract class, it cannot be instantiated, just like in any other object-oriented languages. We can override, an interesting fact is that we can override a non-abstract method using an abstract method, and we will see an example. And in this case, it's not necessary to specify the open keyword because they could be extended by default. Let's check an example. Let's see that we have this abstract class car with two functions. The first one is an abstract one, the second one is not. And in the second class, where I want to extend this car class, I override the run function, and I don't want to provide an implementation for compute taxes, so I just use the abstract keyword. We have this abstract class automatically. When I have this abstract keyword on a function, also our class should be abstract. So we will make it abstract in this case, and we eliminate the necessity of implementation for this open function from previously. Interfaces. Inside of an interface, we could have also abstract and non-abstract functions, and we are able to implement multiple interfaces. In terms of code, let's say here we have an interface pet with two functions, eat and sleep, and cat implements this function and just overrides those two functions. When we implement a class, it's not like in abstract classes, it is mandatory to override the function, so to specify an implementation for each function, define it in the interface. Delegation. Usually, there are some situations when we prefer composition over inheritance. And in order to do that, for example, in Java, or maybe it involves to write a lot of code. In Kotlin, we are getting this pattern by free, without boilerplate code. So they offer native support for delegation. Let's see an example in order to understand better the concept. We have an interface, pet action, that defines some actions for a pet. We have also pet color and a singleton that will implement the pet color. In this case, I want to have a singleton for the yellow color. After that, I want to implement the pet action interface by using this printing pet action class, and we just print the message. The delegation appears here. When I create a class, cat, that will use the yellow color, so it will be a yellow cat, and the pet action, it's delegated, so this by keyword means that it will be delegated to printing pet action. So it will get the implementation from here. And the implementation for pet color will be taken from the constructor, so it will be a yellow cat, like I already said. If we want to use this example and to create an instance of our cat, we will get this message. Pet has color yellow, and it's a lot of fish, because we decided to implement this function from here with this parameter as a constructor, inside of the constructor. Data classes. Data classes are like POJOs. So if we want to create a class for an object with setters and getters and constructor and toString and so on, we are able to use data classes. The advantage is that we get for free implementations for getters, setters, equals hash code toString, component n, and we will see what does it mean. We are also able to get a synthetic copy of it. So it looks like it's your favorite, or maybe your birthday, because you get a lot of presents from Kotlin. Let's take an example. In order to specify that our class is a data class, we use this keyword, data. So if we put it in front of the class keyword, the compiler will know that it's a data class, and behind the scenes, we'll generate code for all the previous methods that I specified in that table. To create an instance, like we already discussed, we use the name of the class, character, Mickey Mouse 82. If we want to get a copy of this object, an older copy with 1 year, we just use the copy function, so we will get a copy of this object created here, and we just change the value of the age. Related to the component and implementation, in Kotlin we have the structuring declaration. So we are able to get the values of the properties, so name and age in this case, by using this notation. So we destructure the object based on its properties. So I'm able to get the name and the age only by using this notation. And also, we are able to get the name of the properties by using these functions. And depending on how many parameters we have in constructors, we have the equivalent number of functions. So if we have 3, we will get component 1, component 2, and component 3. In this case, we have only 2. Companion object. Companion object is similar with the static implementation from Java. And in this case, in order to be called, we just use the name of the class and the name of the function. So in our situation, person.callMe. Collections. In Kotlin, we have a limited set of collections. We have list, set, and map. By default, they are immutable. So in Kotlin, we have a lot of immutable components and variables and functions. If we want to get a mutable version, I mean to have a collection on which we are able to change something, we will use the mutable option of them. So we have mutable list, mutable set, and mutable map. In order of writing code, we have the list of functions. So we'll create an immutable list for this one, and mutable list of function that will create a mutable list. Another helpful and interesting feature is that by default, in collections, we have a lot of operators already implemented. So for example, the sum function is already implemented in the collections, or sum by length in this case, it's also already implemented. So it is not necessary to write some extra code. For set, it's the same approach. We have set of and mutable set of. And in this case, we apply the filter operator. So we will filter all the strings based on their length, if it's greater than 3 or not. For map, we have hash map of and mutable map of. And we are also able to get the value of inside of the map by using the brackets. There are some pairs here, actually. That combination whipped cream to cake, it's a pair. So we have a hash map of pairs. Sequence. So we have the collections and the sequences. The difference between them is that the sequences are lazily evaluated. And I have here a very nice animation. It's not done by me, it's done by Florin Muntenescu. And it's very helpful in order to understand what is the difference between them. So we have the collection and the sequence. In this case, the list of objects and colors. When we apply the map operator for a collection, it will make a copy of that collection and apply that function. For the sequence, it will get only the first element and apply the operator. And after that, apply the first. So for the collection, it will iterate in our new collection created. For the set, it will just get the first element and that's it. So sequences are very helpful because in case of collections, we create a copy. Again, for each operation, create a copy of the collection, so we will increase the memory that's used. Coroutines. I hope you are still with me. Are you asleep? It was good lunch, no? Okay. Coroutines. Coroutines are very interesting right now in the programming world. And in terms of understanding and use them, I think we could make a course of 2 days. There are a lot of resources in this area. Coroutines were not launched from the beginning in Kotlin. The past year they were in experimental way, so they were not officially launched. But right now they are in a stable version, and I have here some simple examples in order to understand what's the flavor, and maybe they will help you in your implementations. Coroutines are actually some lightweight threads, and it means cooperation between the functions. When we have a single thread, and we want to run different tasks on that thread, we need to wait to finish the first task, move on to the second one, and so on. If we have multiple threads, we are able to change the execution from a thread to another one. When we have coroutines, we are able to run multiple coroutines on different threads, and also it's possible to get the result of the execution of those coroutines. And some keywords that are very helpful in this area is the suspend function. The suspend function is actually a function that could be resumed or cancelled. And when we have this suspend keyword, it means that we have a coroutine. The suspend function could be called from another coroutine, so we are not able to call a suspend function from a member function. And we also have some builders in order to help us run the operation on a different thread or not. Launches, for example, creates a new coroutine, but it doesn't block the current thread because it waits until the execution is done. So for launch, it creates a new one, but it waits until it's done. For run blocking, it will create a new coroutine, but will block the current thread. And async creates a new coroutine, and we get a deferrable value of that type. For example, if we want to get a string, we will get a deferrable of string. This is their implementation. And if you want to get that value of the string, we need to use async combined with await in order to get the result. Let's see two examples. So, launch creates a new one, a new coroutine, but it doesn't block the current thread. So it waits until it's executed, and after that, it's suspended, and after that, it's executed. What do you think we will get here? So we have this suspending function, so we have a coroutine here. Suspend fun, print Kotlin. It has a delay of 1 second, and after that, prints Kotlin. And in the main function, we have run blocking that blocks the current thread. And inside of the launch, we call the suspend function. What it will print? Hello, Kotlin, great. Now, let's use the same example, but with a small change. We'll remove this call from here. What do you think it will print? No. Sorry? Exactly. It will change the order because it will not wait the print Kotlin, so we'll just print the Kotlin and after that hello. For the launch, it waits the execution. In this case, it doesn't wait. Okay, so what are the main advantages of Kotlin? It helps a lot of the readability. Usually, as a developer, we already know that we spend a lot of time trying to understand our code or the code written by our colleagues. And usually when we have a new function, a new feature to implement, or maybe an issue to fix, the second one appears very, very, very rare. It's very helpful to understand the code without spending too much time on that. So Kotlin, by having those approaches, so on creating, for example, the data class, it's only one line of code, and you know that behind the scenes there are a lot of functions created there that you are able to use. It improves the readability. Interoperability. The first question asked by the developer is if we are able to use the previous implementations in Kotlin. For example, if we already have something written in Java or maybe in JavaScript, if we are able to combine. So, for sure, we are able to combine it with Java, example. Safety. In terms of safetiness in the programming languages, it means that it tries to remove some errors. For Kotlin, they are trying to remove the null pointer exception, and we saw what are the scenarios when we also can get it. So it's not quite fully done. And in terms of tooling, we have a lot of possibilities. We could use IntelliJ, Unreal Studio, Eclipse, and NetBeans. I have here also a small list of best practices. So if you decide to take this language in your project and start to learn it, and you work also with some colleagues, first of all, it's very important to have some conventions and let the team know about those conventions. Don't treat it as a Java or different language with a different syntax, because it's Kotlin and it has its own practices and its own philosophy. The K-linter is very helpful in order to write clean code. It let us know about the mistakes that we could make in the code. Like we already saw, we have a lot of immutability, so we are able to embrace the immutability by using Kotlin. Take care with the double exclamation mark operator. And other than that, even if we are able to write that code in only one line, try to think about you in the next 8 months, when you will go back to your code and you will not be able to understand everything from the beginning. So when you write the code, think about you and about your colleagues. So Kotlin is about developer happiness and productivity. If you want to learn more, there are a lot of resources in this area. Right now, worldwide, there is a series of events called Kotlin Everywhere. So if you search on YouTube or Meetup or Facebook, you'll find a lot of resources created by the organizer and presenters. Other than that, there are 3 great courses on Udacity. For example, this one it's very nice, organized, and they have examples for all the basic functionalities from Kotlin. And also on Twitter. On Twitter, you find a lot of resources, a lot of people that work with Kotlin day by day, and those people are sharing their knowledge on Twitter. Thank you very much.